Hello students, today we shall start with the next unit entitled Difference Equations and Z Transform. So let us begin with this difference equations. Before this, let us consider or let us define the forward difference operator from certain table of values. Consider this. x0, x1, x2, x3 and x4. y0, y1, y2, y3 and y4. X values, they are called as the arguments, and y values they are called as values. This column is called as value column. This is called as the argument. As compared to the independent variable and dependent variable. These arguments, they are equidistant. x1 is equal to x0 plus h. x2 is equal to x0 plus twice h. x3 is equal to x0 plus 3h and so on. Now, this is forward delta operator. The forward delta operator forward difference operator it is defined as forward delta of kth value of y is equal to yk plus 1 next value minus yk. So, delta of y0 is equal to y1 minus y0. So, I put k equal to 0. Delta of y1 is equal to y2 minus y1. Delta of y2 is equal to y3 minus y2 and so on. So this difference of this y1 minus y0 is called as forward delta of y0. y2 minus y1 is equal to forward delta of y1. y3 minus y2 is forward delta of y2. y4 minus y3 forward delta of y3. This is the basic and fundamental concept. We generalize this concept now. This is the first order forward difference operator. Now, second order forward difference operator. Delta square of yk is equal to the difference of first orders. Yk plus 1 minus delta of yk. Second order difference of yk is equal to difference of the first order differences. Delta of yk plus 1 minus delta of yk. But what is delta of yk plus 1? It is yk plus 2 minus yk plus 1 minus delta of yk plus 1 minus So it is equal to yk plus 2 minus 2 times yk plus yk plus 1 plus yk. That is how we define the second order difference. Similarly, we can define the higher order differences. Now, consider these 4 values of arguments and 4 their corresponding values corresponding to these arguments. Now, this is x0, x1, x2 and x3. This is y0, y1, y2 and y3. I am going to calculate the first, second and third order differences of these values. Now delta of y0, this is y0, this is y1, y2 and y3. Now forward delta of y0 is what? y1 minus y0. So 45 minus 32, it is 13. Forward delta of y1 is y2 minus y1, 52 minus 45. Forward delta of y2 is y3 minus y2, 62 minus 52, it is 10. So these are the delta of y0, y1 and y2, these 3 values. Now delta square values. Delta square of y0 is delta of y1 minus delta of y0. So it is 7 minus 13 minus 6. Delta square of y1 is delta y2 minus delta y. 10 minus 7, it is equal to 3. And delta cube of y0 is delta square y1 minus delta square y0. It is 3 minus minus 6. This 9. So for these 4 values, we can reach up to the third order differences. If there are 5 values, we can reach up to the fourth order differences. So if there are n plus 1 number of values, we can reach up to the nth order differences. So this is the concept of forward order, forward delta difference operator, forward difference. One more operator which I studied is called as shift operator. It is denoted by E. Shift operator. It is defined as E of yk is equal to yk plus 1. It gives us the succeeding value. yk के बाद की वैल्यू क्या है? yk plus 1. So it is shift, forward shift of yk is yk plus 1. It is simple definition. It shifts the value of values I values. E of y2 is y3. E of y10 is y11. E of y100 is y100 plus 1 and so on. So that is how this is true for every case. we define the shift operator. Now relation between shift and delta. E is equal to 1 plus delta, or delta is equal to E minus 1. Let us establish this relation between E and delta. We know that. What we know? What is delta of yk? It is yk plus 1 minus yk. This is true for every k. First order forward difference operator, delta. But what is yk plus 1? It is E of yk minus yk. So it is in particular equal to E minus 1 times yk. So forward delta of yk is E minus 1 of yk. Therefore, forward delta is equivalent to, or it is equal to E minus, or E is equal to 1 plus delta. So, now, difference equation, definition of difference equation is an equation, number 1. That equation involves various differences. Differences of what? Differences of values, or differences of unknown function. Let me define this. It is an equation of differences of unknown function. For example, delta of yk minus 2yk is equal to 0. This is a difference equation. What is the value of delta? It is equal to E minus 1. Delta is equal to E minus 1 into yk minus 2yk equal to 0. So E of yk minus yk minus 2yk is equal to 0. E of yk is yk plus 1 minus 3yk equal to 0. So this is an alternative form of this difference equation. Conventionally, difference equations are denoted in this pattern, in this form, in this fashion, in this type. And we are going to study the linear difference equations with constant coefficients. So, let us define the linear difference equation with constant coefficient. The difference equation of the type which type? A0 into e raised to power n of yk plus a1 into e raised to power n minus 1 of yk plus a2 into e to the power n minus 2 of yk and so on up to an into yk equal to some function of k. Or this equation is of the type A0 e raised to power n of yk means what? It is y of n plus k. N plus kth value of y. Likewise. So, A0, A1, A2, A3, they are the constant coefficients. E is a shift operator. We are going to solve such type of equations. It is as good as the linear differential equations with the constant coefficient. There is a difference between difference equations and differential equation. Difference equation is the equation of differences from the discrete values of the table. Differential equation is the equation involving differential coefficients and their derivatives of continuous function. If we have the discrete values instead of continuous value, the differential equation reduces to difference equation. That is the basic difference between difference equation and differential equation. It is the differential equation of discrete values. So, this is further equal to A0 e raised to power n plus A1 e raised to power n minus 1 and so on up to an in bracket yk is common is equal to f of k. This bracket is called as phi of shift operator E into yk is equal to f of k. So this is called as the symbolic form of the difference equation. It It is written in terms of shift operator in the very first step. So, the general solution is equal to CF plus PR. As we did in linear differential equations with constant coefficient. Now, what is complementary function? Complementary function is CF is the solution of auxiliary equation phi of E equal to 0. In linear differential equation, we used to find out auxiliary equation by solving f of d equal to 0. Here, phi of E is equal to 0. Now, we shall discuss the method of solving auxiliary equation. To find CF. Method. Step 1. Solve phi of E equal to 0. This is auxiliary equation. Case 1. If A1, A2, A3 and so on up to AN are real and distinct roots, then CF is equal to C1 into A1 raised to power K plus C2 into A2 raised to power K plus C3 into A3 raised to power K and so on up to Cn into An raised to power K. Case 2. If A1 is equal to A2 are real and repeated roots, then CF is equal to C1 plus C2K into A1 raised to power K is the complementary function. Case 3, if A1 equal to A2 equal to A3, suppose there are 3 roots repeating thrice, then CF would be equal to C1 plus C2K plus C3K square into A1 raised to power K or A2 raised to power K or A3 raised to power K. All 3 are equal. Case 4. If alpha plus minus I beta are roots, then CF is equal to, how do we determine? It is equal to alpha square plus beta square raised to power K by 2 into C1 cos K theta plus C2 sin k theta. Question is, what is theta? Theta is tan inverse of beta by alpha. The method is exactly similar to that of finding out the complementary function for linear differential equations. So this is the case for real distinct roots. This is the case for real and repeated root, twice, thrice, and so on. This is the case for complex and conjugate roots. So subject to this, we shall continue this in the next lecture. Thank you very much. Thank you.